In this video, I will discuss three functions: draw dimension lines, draw reference points, and draw reference planes. Draw grids I have discussed in the previous slide, in the previous video. So in this video, I will also discuss little bit about draw grids in the inclined plane. So here A, B, C, 1, 2, 3, 4, 5. If I want to draw a grid between A and B, for example at a location 5 feet from A above, so how I can draw? I can draw by the option draw grids here. So here the software asking from me the how much so basically I want to draw 5 feet, so 5 into 6, 60 inch, so it's upward, so it's positive value. Okay, so I will click from here to here. So now you can see I have drawn the grid 1. So similarly I can draw in the inclined plane, for example 0. So I want to draw a grid from wherever you like, here to here. So in this way you can draw the inclined grids. You can rename the grids, for example x1, x2. So I will discuss here. Edit grid data, modify. So here you can rename it, for example x1, caps lock x1, x2. Take so you can also the bubble location at the start or at the end, start, or its location also, second one at the start. Okay, now you can see x2 and x1. So now there is a third option. You can also draw by manually putting the coordinates. For example, I will draw add new grid x3 and I will put x1 y1, x2 y2, means 2 points, so it will automatically draw the grid between 2 points. Now the third option is I want to draw dimension lines. So here dimension lines, I want to check the dimension between any grid. For example here to here, you can check 10 feet any, for example the incline here. So the third option is draw reference point. Why we need reference point? For example, if I want to draw a hole in a slab, so or draw a beam at different locations, so for all these purposes I use draw reference points. So here is draw reference point. For example, I want to draw a reference point. For example, I want to draw a beam from this point to this point, from center to center, or maybe at 5 feet above from the B axis. So here I will put in the y direction offset 60 inch, means 5 feet. Here I have drawn 1 point, here I have drawn second point. So now these are just reference point for my drawing purpose. So now when I draw member beam, so it will automatically pick these points. Okay, then the drawing will be accurate. So here, okay, so that's how draw points work. So the last option is draw reference planes. Reference planes are the elevations. For example, in the elevation plane, I forgot to draw any other story. For example, there is a mumty or there is a landing of stair. So for example, there is a landing between story 1 and story 2. So I forgot to draw the plane, so I can draw by draw reference planes. Here is offset. So for example, that will be 6 feet above or 7 feet above. I am putting 84 inch. Okay, 7 feet from above this point. So here is the reference point 1. You can also rename. So I have drawn the reference points, reference plane, so you can all so see all these things in the edit stories and grid systems. Here modify. So here is the x data and y data which is I have created in the previous video. So that is the general grids which I have drawn inclined and the other x1 and x2. So here is a reference point data. Here you can it's also up to you, you want to remain it's visible or not. These are the coordinates x and y. Cancel. Here is the reference plane and that is 19 feet from the base. So I am naming it as landing of stair. So again it is up to you, you want to keep it visible or not. Okay. Now you can see the ETABS renamed the reference plane to reference plane landing. Hi, in this video I will show you how to draw grid lines in ETAB. So here is the grid lines A, B, C, the distance between them 15 feet and 15 feet, and in the x direction 1, 2, 3, 4, 5, and distances are 10 feet, 10 feet, 10 feet, and you can change according to your requirement. So now in the ETAB I will start from scratch file, from new model. So I will use, there are 3 unit system, so I will use built-in setting with US customary system. Here there is also metric MKS, so I am using US customary unit system. So these are all the settings which I will discuss later. Okay, so basically I will draw the grid lines by myself manually, not the pre-planned by the ETABS. So here I have clicked blank document, blank file. Okay, now I will go in the edit stories and grid system. Here is a default G1. I will click it, modify, and you can delete and click on add new. So these you can play with these settings. Here I am clicking modify. In that there is no grid lines in the x data and the y data. So I will create the grid lines in the x and in the y data. So here I have clicked. So you can draw grids the whichever method is suit to you. So here display grid data as ordinates, display grid data as spacing. So I am basically feel easy to play with display grid data as spacing. Here add, for example I am naming A. Sorry, that is x1, 1, 2, 3, 4, so that's why I am naming 1. Here is 2, here is 3, here is 4. So the first is 10 feet, second one is also 10 feet, third one is also 10 feet, and the distance between third and fourth is also 10 feet. So let me check. There is a 5, so I will draw one more grid here, and again set the spacing 10 feet. So you can also check or uncheck these whether you want to see the grid lines on your model. So here visible, no or yes, and I will also discuss what are these, and at start, at both ends, or none. So now I will move in the y grid data. I will draw 3 grid lines A, B, C. First one is A, second one is B, third one is C. So I will put the spacing 15 feet between A and B. Between B and C, the spacing is also 15 feet. So now you can also see the same grid I have generated as I have already drawn in the AutoCAD. So here is the bubble size. You can also adjust the bubble size. For example, I am making it small. This is 14 inch. So you can adjust according to your requirement or your visibility. So for example, in the display, here is the basically x coordinate and y coordinate. That is the 0 0 means the global x and y. If you change here 3 and 3, then you have to also set the grid origin as per your requirement. You can change the grid origin as per your requirement. So about the reference points, reference planes, and the general grids I will discuss in the next lectures. Okay, so let's see, is it creating, will it create ETABS the grid? Okay, so now you can see A, B, C, 15 feet, 15 feet, 10 feet, 10 feet, 10 feet, 10 feet, and X and Y at the 0 0 location. So that's all. Thank you. In this video, I will show you how to import the grid system from AutoCAD to ETABS so that we can draw our beams, columns as designed or architectural model in the AutoCAD. So here I have created a simple grid system. Here is the distance between two bays is 15 feet and 15 feet, and similarly in the x direction 10 feet, 10 feet, 10 feet. And in the real models, in the architectural, you will see grid system and also the walls, bed system, maybe electrical wiring. So for the import to the ETABS, you have to delete all the items and you should left only the grids. So here is the grid system. So for before the import to the ETABS, you should delete the rest of the items and you should left only the grids. Here I will also delete these grid spacings. Here now you can see only the grid system is here. I will select all the grid and rename it to only one layer. So there are 0 def. So here is a layer name 0 I have assigned, and now I will check the units. Here the units are the inch system. So let's go into the ETABS, file, new model. Here is a unit system, metric SI, and I will select US customary. Okay, and I will take as a blank document because I am importing the grid system from the AutoCAD. Okay, now I will check the units. Okay, here is also inch, so that's okay. In the AutoCAD that is also inch. So now I will go into the import. For the import, you should save your grid system into the DXF file. So here is the DWG file. So I will save as, you can click from here and also from here save as. Here I will select DXF format. So here I am saving my model into the DXF format, save. Okay, now I will again go file menu. I will select import DXF file of architectural grid. Here I have select OK. So my layer name of the grid system of all the grids is 0. So I have selected, and the DXF file units also int, so I will just hit OK. So now the ETABS is saying please save your model, so I am saving my model project 1. Okay, so now you can see all the grids are appeared here. So here 1 2 3, but in the in the AutoCAD that is A B C, and the distance between them 15 feet 15 feet 10 feet. So I can check into the edit grid system data, modify. So here after clicking on display, that is in system, so I have to just convert back into the default units into feet, so that I can check. Here is it 10 feet 15 feet 15 feet, but when you will go into the tabs, so here you will see the spacing also in the X 10 feet 10 feet, but in the Y direction 1 2 3. You can also name here as it is named in AutoCAD A B C. So now we have imported as we seen in our AutoCAD model. So here ABC appearing in the end, so I will also make it at start. So the model is now looking same as in the AutoCAD. So you will also face one error. Here is that, so here is a spacing 3.0605. why I am saying, because when you see the I will click here, you can see in the right there is a coordinates 3.06, that is not showing the 00, means its X and Y is not at the 00. So how will you make it? Simply edit grid storage data, modify, and you will put here with X coordinate minus and the Y coordinate minus, so it will put the XY coordinate system into 00 location. So here I am putting minus 3.0605, that is the X. Here is minus 6.8813. okay, so now I will hit OK. Okay, now you can see the X and Y in the ETABS. In the plan view there is X and Y, and the vertical direction there is Z. So here that is 0 feet, that is nearly 0 feet, and you can see if the Y coordinate 0, 15 feet and 30 feet. So that's how you can make your X and Y coordinate system to match your drawing. In this video I will show you how you can create a new project in ETABS. You will go in the file, new model. If you have already saved a model or working in a model, you can use open. There is also other options. So now in this video I will creating a new model. When I click the new model, then there will be 3 settings appear. First one is use saved user default settings. In this setting you can, for example, you are working on a project, you have created a material, for example 3000 psi, 4000 psi, and steel bars 60 grade, 40 grade, and also you have selected the unit system, for example for the bars area bar, inch square, and for the weight calculation, loading kg, in kg or kilonewton. So all these settings you have saved in the previous model. So you can also save your unique these settings for yourself. For example, whenever you open a new project, then you can just click, it will automatically bring the settings which you have saved for your ETABS software. Then the second option is use setting from a model file. In this option, for example, you have multiple projects, steel project, concrete project, or maybe wood project. So for example, you are going to start a concrete project, so all the sections, all the materials are defined in some in some model. So you have to just click, then the software will ask where is that model. You will just click, software automatically bring the settings from that model. Now I am again going back, file, new model. I am not taking, so you can study by yourself. Here is the third, use built-in settings. So I am basically working from a scratch file, so that's why here is the display unit system, metric, SI, US customary, FPS system, MKS system. And for example, for steel section database, here is the latest AISC 14, and if there is M, it means it is a metric system database, and it is a FPS system database. So steel design code, here is also previous design codes and different countries design codes also present, so you can select according to your country. In the concrete design code, there is also many codes, for example Italian, Hong Kong, Canadian, ACI, American Concrete Institute code. So according to your requirements you can select your model. So here I will click, I am selecting the third setting, use built-in settings with. Okay, here is a different options. I want to start from a blank document, and if my grids are easy or not have some complex guideline grid lines, so I will just create X grid lines, Y grid lines, how many number of stories, so you can change here and just click, then automatically your model will be open. For example, here that the number of grid lines is 4 in X direction, I am just making it 6. Number of grid lines in the Y direction 4, that's okay. Spacing of grids in X direction, that's the 24 feet, just I am making 15 feet, letting it 24 feet in the Y direction. And here is the number of stories, just for example number of stories are 4, just I am making it to 11. Typical story height and bottom story height. For example, your bottom story height, which is a ground floor story, mostly its height is larger than the rest of the stories. So for example, the lower story is 15 feet and rest of the above stories are of 12 feet, and you can also select what value you are going to design. So here I have selected the grid only. Okay, so there is also another other options that are the templates already given by the ETABS software. So here is steel deck, staggered truss, flat slab with perimeter beams, waffle slab, two-way or rib slab. So I will also discuss one of these. Here I am hitting OK. So you can see X and Y. So here is the spacing 24 feet, 24 feet, 24 feet, and here is the setting which I have selected 15 feet, 15 feet, 15 feet, 15 feet, 6 in one direction and 4 in the as given in the start of the model. So here is the 3D view of grid system. Here is the stories. So I can also edit whatsoever I like. For example, I will go in the edit stories and grid system. So here is 11 stories. I also can change the story heights. For example, here that's all the editable. For example, 10 feet, and it will automatically calculate the elevation. Okay. So similarly, the grid X and Y grid data, you can also modify the spacing. For example, 15, 15, you can change according to your requirements. Okay. If there is something like this happen, just click here, it will automatically refresh your model. So now I will again create a second new model. Before creating a second new model, I will just save my model, save as, that is new project. checked 1. Okay, now my model is saved. Now I will create a second model, new model, use built-in setting. Okay, so now I will select a one template, for example flat slab with perimeter beams. So here is the grid line. If I am satisfied, I can change. So I am just in this time I will just play with flat slab with perimeter beams. Okay, so now the new pop-up window asking from me how much overhangs, just like the cantilever portions over the slab, 0.5 feet. So whatsoever I can change 1 feet. In the x direction, left edge, right edge. In the y direction, draw panels, it's up to me, I want or not. So let it be happen as given in the template. Fixed. Restraints at bottom means boundary conditions. Pin, hinge connection, fixed boundary conditions. That is the diaphragm, rigid, semi-rigid, no diaphragm. Here is the loading condition, we can also apply here. For example, dead load, additional, the self weight, the software automatically calculate. So here I am putting the additional dead load, which is super dead load, that is the 50, and the live load is 100. Concrete column, all the sections are selected. So you can also edit at the later stages. Now here I am clicking OK. Model is template is selected. OK. It will take just some seconds, then this will appear. So here your model is appeared. You can also change the number of stories, all things that are created by this template are editable. In this video I will discuss about the layout of the ETABS. So in the ETABS, that's the top bar, which is a menu bar, that is the standard toolbar, and on the left side that is a draw toolbar, and there is a down, there is also one toolbar, that is a I can check, that is a select toolbar. So here if I uncheck, that will appear. So here, so I can also enter more toolbars according to my requirement. Here is a model explorer. So all the settings, for example the material property, section property, are present in this model explorer. You can also see display results of analysis results in tabular form, in report form. ETABS generate a very good report for their users, so that they can study in detail. So last one is the detailing. If I generate the detailing by this software, then all these properties will appear here. So for example, at the startup in the model, so for example here is a project information, project and design preferences, structure type, stories. In the properties, for example what concrete is used, what column size is, so all these settings. For example material, so here is a 4000 material is used, frame sections, concrete column. For example I can click modify and see what is the column concrete strength is 4000 psi. So all these settings, I mean to say, is present in the model explorer. So here file for the opening of new model, saving new model, saving working model. So all these settings, import, export, all these settings are present here. Your project information from the start, you can enter the project information, client name, company name, revision number, all these settings, who is designing, you can enter. So when you enter at the end, when you generate the report, these all settings will appear at their places. Second one is edit. If you want to edit any grid story data, member, so all these things are present here. View, you are want to see, for example here is the axis appearing, I do not want to see, that will go. Then if I want to come back the axis, here I'll just click, the axis will come back. define materials, load patterns, load combinations, all these settings are present in the define for the according to the definition. Draw, so if I want to create a slab, beams, columns, edit, so all these settings are present here, walls, etc. Select, a small select toolbar is also here, and the major, that one is present here. Assign, if I want to, for example, boundary condition, spring constants, all these settings are also present here. Okay, then the next is analyze tab. There is also present in the standard toolbar. Run bar, that is also present in the analyze toolbar. For the checking model, for example, if I click here and select all, how much accuracy I want, I will just click OK. It will check the whole model. If any ambiguity or wrong modelings appear, then all the errors will appear here. Now it is saying model has been checked, no warning messages were generated. Display all the display results, for example, shear forces, bending moments, axial forces, all these values will also appear here. And if you want to some more results about the slab stresses, all present here, deformation, etc. Design, when you are going to design, then you will definitely go in the design tab for the design of steel structures, concrete structures, composite sections, slab designs, and there is also a new option, steel connection design for ETABS, for latest ETABS. Here is a detailing, and for example, when you are going to detail, then it will ask what sheet size you are using, what units are you using, rebar selection rules means for columns what bar you prefer, for beams what bar you prefer, all these settings are appear. After selection you will create. Definitely this option will come after analyze, after design, then detailing. Options, so for example, setting of the tabs are present here. For example, I have just told you, you can save the unit system. For example, for this model, I have used unit system. Here is a fit metric, sorry. So now you can see all the units have been changed to metric, and I have defined the section properties, material properties. So if I want to save my all these settings, I can save in the options. Here is a save user default setting. Now these settings will become the default settings. Graphics, tolerances, for example, all these things are pairing 7 point with 4 decimals, so you can all things change here. Here is a tools. ETABS also offer different plugins. If you have, you can use here option. Here is a ETABS help, that is a very good. You can study, and even the documentations, there are much more information is given. For example, in the concrete frame design, for example, ACA 314, when I double click, it will show me the design manual for the concrete. For example, if I am facing any unit understanding, any symbol issue of understanding, so I can consult the manuals. So that's all about the layout of the ETABS. Thanks. So last one, that is the model windows in where we work. So you can also create multiple windows. Just default windows are 2, that's the plan, that's the 3D window. You can adjust according to your requirements. So that's all. Thank you. Have a nice day. Now I will show you how you can apply on beams, UDL, VDL, point loads, all simple types of loads in a simple example. Here I will click File, New Model, use built-in setting. Okay, I will just grid only. The grid is already created. I will click OK. Okay, here is a to D grids, 1 to 4 grids. I will select A grid, go to the elevation, apply. Okay, so now I will draw just one beam. I can also selecting the another option, draw beam. Here I will select my beam. Because I have created a new model, now my previous one is not present, but I can select the option from here, select all the material from the existing model, that is also option. So just I will click here, concrete beam, from here to here. Okay, here is the beam. Here I will apply the support condition. I have selected the joints, assign, joint, restraints. So here are all three boundary conditions or supports: fixed support, hinge support, roller support, and non-support. Here non-support, fixed support, deformations and rotations all are restricted. In the hinge support, movements are not restricted, only the displacements. And for roller supports, only the vertical direction will be selected here. So now I have selected the beams. I am assigning the fixed supports on both the sides. I have clicked apply. Okay, so fixed support symbols are look like this. I will select the beam and go to assign. Here I will select the frame loads. Here is a point load. If I want to apply the point load, here is a live load. I will just select where I want to apply the point load. From this end, how much distance? For example, the total distance is 8 meter. You can see here that is a y 0 meter, and here is the y 8 meter. So I want to apply, for example, at 3 meter from the left end. So I will just select the there is a ratio wise. It's 25% location, 75% location, 100% location, but I am suitable with distance. I will just select the distance. For example, I want to apply the load at 3 meter point load, and the value is, for example, roughly 40 kilonewton. I will apply. Here you can see the point load is applied. And if I want to apply another load, do not want to replace the load from this beam, then I will select again the location, for example 7 meter, and apply the load of 70 kilonewton. Now if I just apply the software, remove the previous load and apply the new load, I will just select the add to existing load, apply. Sorry, I have not selected the object. Before applying the loads, I have to select the object. Now I have selected, and okay. Here you can see you can apply the loads by point loads. Now I will again select the beam and assign. Now I will apply the UDL or VDL loads. So for VDL, for UDL, there is an option at the bottom. Just click, for example, I want to apply 5 kilonewton per meter load on the whole beam. Now this is VDL, UDL, not the point loads. Software will not remove, or for your satisfaction, or you can check later. Here I am just clicking add to existing load, that is a live load, apply. Here is here is the load 40, 70 and the UDL load. I can delete the existing loads from the beams. For example, I have selected delete the existing loads, apply. Now UDL load is removed. For point load, I have to go back in the point loads. Okay, let's see here, assign, frame loads, point loads. I will select the delete existing loads here. Now I have removed the loads. Now I will show you how you can apply the VDL, varying distributed load, uniformly varying distributed load. So here I will again assign, frame loads, distributed loads. So I will use the option absolute distance from IN. I will select at 0, the load value is 0, and at, for example, 5 meter, the load value is 8 kilonewton per meter. I have selected the beam. I will click apply. So here you can see basically from 0 to 5 load is 8 kilonewton meter, and there already option is selected, so I will just put here 0, apply. That is now I will show you how you can apply VDL, uniformly varying distributed load. Assign frame distributed load, and here I will select the absolute distance 0, the load is 0, and at location, for example, 7 meter, the load value is 10 kilonewton meter. 0 value is 0, at 7 meter the value is 10 kilonewton meter. So here software automatically draw the VDL. So on the beams you can draw any types of loads according to your requirements. So that's all of load assigning in ETABS. The load patterns that we have defined in the previous lectures, now I will apply that loads on the buildings. So here are the load patterns which I have defined in the previous lectures. Now I will select all the slabs and apply the loads. Here I will select object type, floors, select. Okay, I have selected all the floors. Now I will go assign. Before going into assign, I will show you how you can pick the load types. For example, how many live load should be applied on any building, either it is commercial building, residential building, hospital building, and maybe nuclear reactor plant, and anything. It's a stakeholder facility. So all these types of buildings, how many loads are applied, how many live loads should be applied. For example, here is the ASE 716 minimum design loads and associated criteria for buildings and other structures. For example, I want to see the load types. So here is a, for example, load combinations. Here is a basic load combination with that live, wind, and for seismic. Here is a basic combinations with seismic load effects. So these are the basic combinations which is software automatically make in the default design combinations. Now I will see the how much live load should apply on any building. For example, first we have to make sure from our client what type of this building, either it is residential building, plaza building, office building. For example, let's see this is the office building, then how much load should be applied on the floors. So I will go in the live loads. Here minimum uniformly distributed live loads and minimum concentrated live loads. So if there is a office floor system, then office use the minimum uniform load is 50 pound per square feet, and the inner bracket values are in kilonewton per meter square, that is a 2.40. Live load reduction is permitted, yes. Multiple live story reduction permitted, yes. Means we can also apply or select the values in the ETABS that live load reduction is suitable. So that's how we will pick all the values. For example, in hospitals, patient rooms, corridors, above first floor. Similarly, if a generator room, high machinery room, all types of loads are present in this. For example, storage areas. So you can pick the load type in pound per square feet or in kilonewton per meter square. So right now I am selecting the office use, then I will apply the load in pounds per square feet or in the kilonewton per meter square. Here I will select the slabs and apply 2.4 kilonewton per meter square. I have selected all the slabs and go to assign, shell loads, uniformly loads, and in that I will select live load here, that is in pound per feet square. Then what should I have to apply? That is 50 pound per square feet. 50, apply. Now you can see load is applied on all the floors. Now I will again select this all the slabs. I do not have to go into the select and select the here is the option previous select, get previous select. Here again all the previous selection is available. Now I will apply the super dead load. In the super dead load mostly comes the floor finish load, uh, like pipe fitting. So all these types of loads are come in the floor finish. So for the floor finish I will apply 30 pound per square feet. You can calculate in that what type of material is there, either is a tile or brick ballast. So all these types of things you can calculate for the super dead load. Apply. Here I have applied the super dead load, live load, and the dead load, that is software automatically calculate the self weight of the whole structure, because we have applied the self weight multiplier in the load patterns. In the load patterns we have applied the dead load self weight multiplier 1. That software automatically calculate the self weight of whole the building. Now for the applying of line loads on the beams, first of all I have to draw the beams, because I haven't drawn the beams yet. So here I will select the beam, that is a draw beams. Here is a quick draw option, and from here I will select my beam type. Here is a beam 300 by 600 millimeter, which is I have defined. I will enable that my model and click here. Then only one beam is appearing. I want to draw the beam, Ctrl Z and select all stories. When I will draw beam in one story, automatically the beam will be drawn on all the stories. Now you can see the beams are present around all the slabs. Here when I click I can deselect, or by escape I can deselect the drawing mode. Now I will select all the beams. Select, here is the object type. Here is another option from frame properties. Here is the beam. Select, OK. Then I will go assign, frame loads, distributed. Here I will select super dead load, and how much will it be? Uniform load in kip per feet for a height of 3 meter or 11 feet walls. So here is a load sheet. I have calculated, for example, that load of 9-inch wall to 230 millimeter thick wall, and here is a total load of height of building 3 meter. Then again extra load is calculated for the plaster, 1.6 kilonewton per meter, and the total load is 12.433 kilonewton per meter. Now the load is converted into 0.852 into kip per feet. So I will apply 0.852 kip per feet load on all the walls. Apply here. You can see, close, ready. Load is applied on all the walls. So similarly you can apply the loads according to your conditions on slabs, columns, etc., depending upon your requirement. I have defined the load patterns in the last lecture. In this lecture, I will show you how we can define load combinations in ETABS. Here is the tab of load combination in the define. For example, when we do the manual calculations in our graduate program, so we oftenly define the load combination 1.4 dead, 1.2 dead plus 1.6 live. So how software take automatically, here is the option add new load combination. Here is, I will type the name 1.4 dead, and here is the load type 1.4 dead, that is dead. I am converting it to 1.4 dead. There is also one more load, that is super dead, that will also the factor of 1.4. So here under the 1.4 dead, all the dead loads are coming and the factor is 1.4. And here is the other option, another option, that is load combination type. There are various load type combinations, that is the linear, envelop, absolute add, S, R, double S, square root of sum of squares, range add. These are different, but for our designing, normal designing, so whatsoever we did in our bachelor programs or master program, we use the linear addition. So for example 1.4 dead, 1.2 dead plus 1.6 live, these are all linear addition. So there is also another option, for example the envelop. For example, you have different combinations, 1.4 dead, 1.2 dead plus 1.6 live, and 1 dead plus 1 earthquake plus 1.3 live. For example, these are three combinations. So software in the envelop option, software what software do, basically software take the maximum values from these three combinations and make an envelop. Envelop is the peak values, so software automatically do. We do not use the envelop for our designs. These are just for checking of load combinations peak values. So for the design we only use linear addition combination. So now we have defined the multiple load patterns, that is dead, live, earthquake and wind. So there is a very good option in ETABS. Software automatically define the load combinations in ETABS. For example, I will show you here, add default design combinations here. So for example, now I am designing the concrete building. I will just click here concrete frame design and convert to user editable. Means software will also allow to edit these combinations. Here I will click OK. So software automatically created the load combination. For example, I am checking here modify, software automatically created the option here. So that's how software automatically make all the combinations. We can also edit. For example, second one, modify, I am changing the name it to 1.2 dead plus 1.6 live. Here the names, I will change the name of all these combinations, so I can understand what is present in these combinations. For example, ultimate design load combination 12, here 1.3 dead, 1 live, and -1 earthquake. So that's how software automatically make the load combination. So that's all for the load combination. In this lesson, I will discuss about the mass source. The mass source is a very important tool for the seismic analysis. In this seismic design, for the lateral loads, we need mass source. For example, here is a ASC 716 code. In that, for the calculation of base shear, here is the formula V is equal to CSW, where CS is a seismic base shear coefficient and W is a seismic weight. So how much seismic weight will be included to calculate the base shear? So that term is called mass source. I am repeating again. Mass source is that mass which will be used for the calculation of base shear. For the lateral loads calculation in the seismic design, we use mass source. And what is included in the mass source? For that, here is a effective seismic weight per here. I will click here. Here is a effective seismic weight. What is coming under? I will read later. First of all, I want to go in the options, define mass source. Here is a default mass source which is defined by the ETABS. I will modify and discuss the parameters here. Here is a mass source. Here is the default options, that element self weight, automatically self mass, automatically ETABS take the self weight of each element, and if any additional mass is assigned, also take. And there is second option specified by load patterns, that is given by the code. We will use that option. I will read that parameters and then apply in the ETABS. And third option is specified load patterns, that the option will I will use. The fourth option is adjust the location of mass source in the diaphragm. You can change if you want, but I do not want to change the mass source location or provide the eccentricity. I do not want. I just want to use the standard method, specified load patterns. Here is a what is the how load patterns should be used. Now I will read the effective seismic weight. In the effective seismic weight, W of a structure shall include the dead load. It means all the dead load will be included in the seismic weight above the base of the ground level, above the ground level. In areas used for storage, a minimum of 25% of the floor live load shall be included. Means we have to consider the live load 25%. Where the inclusion of storage loads adds no more than 5% to be effective at the level, it needs not to be included in the effective seismic weight. So need not to be considered if that is 5%. Floor live load in public garages and open parking structures need not to be considered. It means live load need not to be considered. The minimum value is 25%. Where the partition loads is minimum of 10 pound per square foot can be used. Partition load, for example, if in the floors we are using a movable partition, or we have made a steel partition or any material partition, so that load should also be considered in the effective seismic weight, and that load should be considered in the effective seismic weight. If any machines are present, for example lathe machine or any heavy machines, then the loads of that machines also included in the effective seismic weight. For the snow load, that for the snowy areas, weight of landscaping and other materials at roof gardens and similar area need also to be considered in the effective seismic weight. In our model, for example dead load, I will consider as 1, because all the load self weight will be considered in the mass source. Then super dead, also 1, all the floor finish all considered all the dead loads. Then there is a live load. Now I will consider it as 0.25, because 25% modify. I have modified the load patterns. So that's how we define the mass source by using load patterns. So there are 3 options more. Here is the first option, include lateral mass. In the lateral mass, the mass source components X and Y will be considered for the mass source analysis, not the Z component. If we check the third option, then the Z component will also be considered. But Z components is so much low, we are almost ignore that component. So these options are checked. And third option is lumped lateral mass at story levels. This is the basic theory of lumped mass approach, because all the self weights or mass source are considered to be targeted or present at the story levels. So that's why I have checked that according to the lumped mass approach. So that's how we define the lumped mass in ETABS. So that's all for lumped mass. Okay. Have a nice day. In this video, I will show you how you can define material properties for your project. For example, you want to define the material property for concrete section, for rebars, for reinforcement, and for steel sections. So all things you can do in the define in the menu bar in the define material properties. There are already default properties 4000 psi, 50 grade, 60 grade, 270 grade. These are the predefined. So I will define the materials from the scratch. For example, now I am going in the define, add new material. So here is a, for example, region China, Europe, India, United States, or if you are using an ASTM materials, for example, reinforcement for 20 grade, so definitely that will satisfy the ASTM standard. So you can use the respective country. So if the materials of your country is have different properties, you can use the user define. So now I am clicking the United States. In the material type, for example, first of all I will define the concrete. There are many materials: steel, concrete, aluminium, masonry strength. So here I am defining concrete. So standard, there are also preset standard. For example, if I select standard customary, then there is already preset concrete section strength defines, FC prime 3000 psi, 4000 psi, 5000. For example, I am going in the user. I will define myself. For example, I want to define a 28 megapascal strength. So I will click OK. Here I will define FC prime equal to 28 megapascal. So material type is concrete. Directional symmetry type, there is two: isotropic and orthotropic. So our we assume that our concrete is homogeneous, so that's why we will select isotropic. Material display color, you want to change, you can change, but it is okay for me. So for example, material notes, you can write anything. For example, this is a concrete 28 days cylinder strength. So these are just notes you can enter according to your requirement. So this is the concrete density, that's the weight density, and that is the mass density. Here now that is available kg per meter cube. Here is a weight density in kilonewton, 23.5631. If your concrete has some but little different value, then you can change here. So then that's the modulus of elasticity of concrete. Definitely that depends upon the concrete cylinder strength, 28 days cylinder strength. So we will change it later. Poisson's ratio for concrete, that is 0.2. Coefficient of thermal expansion, that is also okay. Shear modulus is this one. So where is the 28 megapascal? That is present in the material property design data. Here is, I have defined the 28 megas, but that is somewhat 27.58. That is due to 4000 psi conversion. So I will put here 28 megapascal. If my concrete is lightweight, I can also put the reduction factor, but I am okay with that, 28 megapascal. Okay. So I will here now change the modulus of elasticity. I will just write the formula for the SI system. 4700 multiply by FC prime is 28 megapascal, 28 power 0.5. I have written that 4700 under root FC prime. So I will hit OK. Software automatically adjusts 24,000 megapascal. So that's all for the concrete. Okay. So here is my material. If I want to make a copy of this material, I will just, for example, I also want 24 megapascal for my slab. For example, this is for columns. For slab, mostly the strength is lower, So I want to define one more concrete material that is of 24 megapascal. I will hit OK. Click on add copy of material. Just name it FC prime equal to 24 megapascal. So here I will put 24. Okay, and again I will also change the modulus of elasticity by the formula of 4700 under root FC prime okay. Now the rest of the things are okay. Okay, now I have also defined the two materials of the concrete. So now I will define a new material for reinforcement for rebar. Here United States. Now I will define the material rebar, that is for reinforcement. That is also preset given, so definitely I will try to select the ASTM A615 that is mostly used. So there is an option if I want the 40 grade steel, 60 grade steel, 75, so it depends upon the requirements of your project or the availability of material. So for example, I am selecting the 60 grade steel. Okay, Fy equal to 420 megapascal. Okay, now that is for reinforcement. Material type rebar, directional symmetry, that is definitely uniaxial. That is the density, that is the modulus of elasticity, that is constant for steel, 200 GPa, 200 gigapascal. So here we can see our properties. Minimum yield strength, if you are using the material, the steel strength mostly come, that is 420, so you can just add it 420, and that is 620, and expected yield strength is basically 1.1 times of this one, and this expected tensile strength, that is ultimate, 1.1 times of this one. For example, I have changed the value of yield strength. I will just multiply 1.1 multiply by 420. Okay, now the expected yield strength is 462 megapascal. Okay, so that is defined, I have defined in the material of 420 megapascal. Okay, so similarly you can also define the material of 3300 megapascal steel. So you can just create add copy and then you can add the properties. So now I am defining the steel property for steel sections, for example W, L. So for these type of sections I will select steel. So here is a grade 50, or mostly in our design section we use ASTM A36 steel. Okay, so let's check its strength, that is a 248. So in our design box or design calculations we use 250 megapascal. So that's how you can also change these properties, but mostly we work with 250 megapascal. That value is okay. For 400 megapascal is ultimate. So you can also study here the rest of the properties, that is the Fy equal to 250 megapascal. Okay, here I will put steel section so that it will differentiate from the rebar. So whenever I select the material, so I memorize that this is properties for the steel sections, not for the reinforcement. So that's how we can define the materials for our project. And in the next lecture I will discuss how we can define the section properties, for example beam for beam section, for column section. So all these properties I will discuss in the next video. Thanks. In this video, I will show you how you can define section properties for beam, column, walls and slabs, etc. So I will go in the define section properties, then click the frame sections. Here you can define the section properties for beams and columns. Here there is a lot of section available. For example, there is a steel sections, concrete beam, concrete column, steel beam, steel column, composite beam. So these are already predefined sections. So you can also define the channel section. For example, if channel section is not available, for example, I will import new properties. So for example, I want to import the steel sections, steel channel section. I will click OK. Then which database, metric database or FPS, mean inch system or metric system. So whatsoever database user like, that can select. So here I am selecting metric system. Here I will select the material property of the, and you can also change for these channel sections. Here is all the channel sections. I will select all the channel section, or if I want less sections, I will select less. You can select up to your requirement. So I will click OK. Then all the sections will be available in the section database. So here is a C sections, W section already present. So now I will define a new section, for example for beam and column. Here I will create a beam section, add new. Here is a concrete, you can select from here, concrete section. So first of all I will define column of 300 by 300 millimeter. So here is the material property. You can select, for example, I want to select 28 megapascal, which is a 4000 psi, that is a 3000 psi. For columns I will select 28 megapascal. And notional size data and display color for the column. Nodes you can put according to your requirement. Section shape, there is multiple shape, for example circular and rectangular for concrete. So right now I am using the column rectangular, 300 by 300, 300 by 300. And here is the reinforcement. I have to select what type of section, that is column or beam, reinforcement type, circular or reinforcement, configuration is rectangular or circular. For example, for the circular column, that will be circular. So now I am designing the column. Longitudinal bars grade, that will be 60 grade, and for the confinement bars, that is also 60 grade, that is defined by me. And here is the option of reinforcement to be checked, reinforcement to be designed. Our 99% we check this option, reinforcement to be designed. It means that we want that software automatically calculate the reinforcement from the design loading. So after design loading, software will show reinforcement. That will definitely for the reinforcement we will discuss in the later videos. So you can select the properties. So here I have selected this option, that software will design the reinforcement automatically. What is in the first option, reinforcement to be checked? For that you have to provide the reinforcement. For example, you are making the trial. For example, first trial you have put 3 number of longitudinal bars in the 3 direction and 3 number of longitudinal bars in the 2 direction. What is 2 direction and 3 direction? In the face you can see here is a 2 direction, here is a 3 direction. I have selected 3 and also the confinement bars. Then after checking, when you check this option, software will check the reinforcement that provided by you. In the second option, software automatically calculate the reinforcement. Okay, here is the section is appearing. So here is the second option, that is the property modifiers. Property modifiers is a very important property for the simulation or modeling of reinforced concrete members. For example, here is a property modifiers for ACI beams should be 0.35 of IG, columns 0.7, walls uncracked, walls cracked, and flat slabs and flat plates and flat slabs, that is a 0.25 IG. That is also present in the ACI building code requirements for structural concrete and commentary ACI 318M14. So here you can also see basically what are these. When we do the numericals in our bachelor classes, we basically ignore the concrete below the neutral axis because concrete is weak, and we ignore the concrete on the tension side. We take on the compression side. So for that purpose of when we go in the simulation, we ignore the lower part and take the upper part. So that's why in the beams we take the 35% portion only, and for columns 70% and falls 70% or 35% according to the conditions, and for the flat slabs and flat plates that is a 0.25 IG. So how we can put these values or use these values in our software? So here is the option. So for ignoring of concrete in the tension side, we put basically I am defining the column, so I will put here 0.7. Okay, and section properties, cross section area, moment of inertia, moment of gyration, all things are calculated by the software automatically. Okay, so that is a column 300 by 300. Now I will create a copy of this column again. Add copy of this column 450 by 450 millimeter. I will again put here 450 by 450. Because I have created the copy, now there is already present the modifiers. Okay, reinforcement, rectangular column, 60 grade for longitudinal, 60 grade for confinement bars. Okay, now I will define the beam, for example 300 by 600 millimeter. So here is a depth 600 millimeter and width is 300 millimeter. When I will go in the reinforcement, I will select that is the beam, not the column. So here is a cover of rebar that is from the centroid to the outer concrete cover, that is a 60 millimeter, and longitudinal bar that will be also confinement, and you can change according to your requirement. Okay, now let's see the property modifiers. We have to also change the property modifiers for the beam. So what are the property modifiers for the beam? That is a 0.35 IG. So I will put here 0.35. Okay, so that's how you can change the concrete properties. Either it is a 24 megapascal or 28 megapascal, that depends according to your requirements. Okay, so here is a beam. Now I will show you how you can define the section properties for slabs. Here is a slab. I will create a new property, add new property, slab 150 millimeter, that is a 6-inch slab, and for slab I will select 24 megapascal and okay, and I will also change here the property modifiers. Here is a property modifiers. So what about the flat slab and flat plates? That is a 0.25 Ig. So here is a for flat plates. If you are modeling as a membrane, then put only F11, F22, F12, 0.25 Ig, and if you are modeling as a shell plate, so then model as a F11, all equal to 0.25. So I will just copy, Control C, and put here Control V. Here, okay. So a little bit difference, what is membrane and what is shell. The membrane, you can imagine a paper of any book, that the paper or have the properties that it have in plane bending behavior, can resist the in plane bending, but out of the plane bending cannot bearable. But in our slabs, that are shell elements that can resist both in plane moments and out of plane moments. These are the difference between the shell element and the plane element. So that's how you can define the slab elements. Okay, now I will define the wall sections. Here is a wall section, add new property. Here is I am defining wall of 200 millimeter, that is of 8 inch. Wall material, that will be 28 megapascal. Wall thickness, that will be 200 millimeter, and the modifiers for the wall are 1 I have to change also. So here I am considering the walls as uncracked, that because that are very heavy elements, I will put 0.70 Ig. Model as shell, and I will put everywhere. Because why I am putting everywhere, because I am considering the wall as a shell element. Okay, so that's how you can define beams, columns, slabs, and walls, etc. in ETABS. So if you change the unit system, for example, now it is appearing 8 meter to, for example, US default, all the units automatically convert into FPS system, but no dimension will change. For example, I want to see my section, frame section. Here is a beam 300 by 600 I want to see. So here you can see the dimensions that are not changed. 300 means 12 inch, that is a basically 1 inch is equal to 25.4 millimeter. Software automatically converted into inch. So 600 millimeter, that is at 2 feet 24 inch. So here, so software automatically convert the unit, nothing will change. For the defining of load patterns in ETABS, I will go in the define load patterns. Here you can define all the load types, for example, dead load, live load, super dead load, earthquake load, wind loads, all load of types, even snow loads you can define in the load patterns. So here by default there are two load patterns defined: dead load, its type is dead, and here is a live load, its type is live. And here you can see for the dead load there is a self weight multiplier is 1. What does it mean? For example, you have modeled the whole structure, then software automatically calculate the self weight of whole the structure by considering that is the dead load of the structure, because we have multiplied with 1. So we know no need to calculate, for example, what is the length, width of the beam or column, then multiply its density. Software automatically calculate the self weight of the structure. Here is a live load, that will be 0, because we will apply on the structure, on the floors, on the beams, that what is the live load. And for example, we want to define a super dead load. So how we can define? First of all, I will write the name super dead. Okay, space. Now I will select super dead load, and there will be no need to multiply because cell weight is already included in the dead. Add new load. So that is a super dead load. In super dead load you can put floor finish, floor fittings, etc. In this super dead load. Now I will define the earthquake load. For example, earthquake in X direction. So for that I will select the type seismic, and from here you can select the code with which you are familiar, then the parameters you can understand. For example, here is a ASC 710 and UBC 97, Euro code, Chinese, there are more standards, for example Indian standard. So now I am clicking UBC 97, add new load. So here you can see I have defined the earthquake load in the X direction, positive X direction. The type is seismic, and the code I am following is the UBC 97. So here I will modify the parameters. So there are all the boxes are checked, so I will just click because I applied the earthquake in the positive X direction. And eccentricity that is allowed by the code. For example, ACA allowed that you can allow the eccentricity 5%. So here is a 5% allowed eccentricity. Time period will be calculated by software automatically, and the method A, for example in UBC there is a method A and method B. So here you can put the parameters for the method A. Program automatically calculate this value vary for concrete structure, for steel structure, for woodwork. So select the value according to your requirement. So user define, if you are not using the time period calculated by the software, then you can define or input your own time period. So I am okay with the software automatically calculate the time period of the structure. So earthquake will be applied from top story is the story 4 to the base. So here top story and the base, and our strength factor are 8.5. What is that? Basically I will come here later. First of all I will go to the seismic coefficients. Here is seismic coefficients per code. So first of all I have to select that what seismic zone where I am going to design my building. For example, it is zone 1, zone 2A, 2B. That depends according to requirements. For example, I am following UBC 97. So then in UBC 97 here is a zone 1, 2A, 2B, 3 or 4. First of all I have to identify. For example, my structure is going to lay in a one city. So I have to identify what is the seismic category of that city. So is it lie in the zone 1, 2A, 2B, 3 or 4. For example, I will select my building is lie in the 2A zone. So here is a value 0.15. For example, in the tab, for example, that is the soil type. If you know the soil type, how you can understand the soil type? Here is a conditions given by the code. Your soil type will be SA if it is a hard rock and shear wave velocity is greater than 5000, and if the soil stiff soil, then 600 to 1200 wave velocity, then your soil type is SD. If that is soft soil profile, that is less than 600 shear wave velocity, then select SC. If you didn't perform the soil analysis or geotech report or on your side, then you can select the value of soil profile SC. Otherwise, I prefer that you go for testing of the soil. If you do not know at the time of designing, you can select SE. So here I am selecting SE, and I have selected the zone 2A. For 2a the parameter is 0.15. So here you can see the parameters for the 2a is 0.15, and if I select 3, then correspondingly the value will be 3 zone 0.3. So here you can also see all the parameters are here, and these are the near source factors. If you select the zone 3 or 4, then you can see the parameters. What is the seismic source type, it's a near source or whatsoever that is present in the UBC. So here I am selecting the zone 2. The software automatically pick the values of CA and CV. And what is the importance factor? Importance factor, for example, if I am designing a hospital building, definitely that is a most important structure. Or if the building is used for religious purpose, then again the building is very important. So I will assign these type of structures the extra factor. For example, I am going to design a nuclear reactor or nuclear plant, then definitely I will assign the importance factor much more than the rest of the buildings, for example residential buildings. So for all the residential buildings the value is 1, for the other buildings the parameters are given in the code. Here is a occupancy category, here is a seismic importance factor. So what importance factor will you apply? This is special occupancy structures. These are structured for residential building. So I will select 1. For hazardous facilities, for essential facilities the parameters is more. Now the last parameter in the earthquake definition is our strength factor, R. Here is the our strength factor, R. So first of all I have to understand what building I am going to design. It is a masonry structure, concrete structure, steel structure. If it is a concrete structure, then in concrete structure we design the structure of the frame, design the concrete structure in 3 ways normally. One is the ordinary moment resisting frame, then second is the intermediate moment resisting frame, and third one is the concrete special moment resisting frame. So for ordinary moment resisting frame we use 3 value of R. For the concrete intermediate moment resisting frame we use 5.5, and for special moment resisting frame for concrete that the value is 8.5. When the frame is lying in the special moment resisting frame zone, that is in the zone 3 and zone 4. For zone 2A and 2B we normally design the intermediate moment resisting frame. So you can put here 5.5 if you are designing in the intermediate moment resisting frame, and put the value of 8.5 if you are designing the special moment resisting frame. For simplification, what is the special moment resisting frame, what is the intermediate moment resisting frame? The basic difference for that is the detailing. You can see the detailing requirement for the special moment resisting frame, the detailing requirement for the intermediate moment resistant frame. Rest of the designing is the same. So that's all for the earthquake pattern defining. Here is a defined earthquake in the x direction. I will again apply a new load for the negative direction. UBC, add new load, that is in negative direction. Modify, I will just quickly modify. Here I will put 5 SC 0.15A. okay, that is load I have defined in the x direction. Now I will define the load in the y direction. That will be plus y. You can define all the loads in the one, but I prefer in different load patterns, so you can, it's up to you. Add new load, modify, minus Let me check the previous one. Okay, I have defined correctly. So that's how we can define the gravity loads and the earthquake loads in the ETABS. When we define these earthquake parameters, the software automatically apply it to the structure. But for the live load and super dead load, we have to apply on the slabs, on the walls, etc. And for the wind loads, I will discuss in the next video. Meshing is a very important feature for finite element analysis. ETABS software uses finite element analysis. Basically, the ETABS software is based on the basic principle of the ETABS software is the finite element method. For that purpose, in the finite element method, we have to divide the object of beams, columns, slabs into smaller parts. Then finite element make the analysis on these small elements and and after combining show the whole analysis results. For example, if we do the smaller meshing size, then it will give us better results, and if we do coarser meshing, then it will give us a less uh, accurate results, and further it will give, but it will give less time to analyze. Inversely, in the other sense, if we do the more refined meshing, then more better results we get, but for that we have to make the time, then the software need more time to analyze, because we have defined our model. So how we define the meshing in ETABS? For example, first of all, I will do the meshing of slabs. So here assign shell, then go into the floor auto mesh options. So there are different options for meshing. For example, default for defining rigid diaphragm and mass only, no, mesh objects into 2 by 2 parts. So there are multiple options, but I am good with the default option. So here it's in the default option, the size of the one box, that is will be 4.1 feet. So the for better results, 3 feet box is okay. So that's why I am selecting 3 feet. Okay, and then I will apply. After applying, basically I have not selected any object. So here I will select object properties. In the object properties, I will select the floats. Select. Okay, you can see all the floats are selected. Now I will click apply. After apply, if the meshing sizes are not appearing, you can see in the set display options. Here is the shell analysis mesh. Apply. Okay, now you can see all these small boxes are appearing. So each box is a 3 feet by 3 feet. So that's how we do the meshing of slabs. For meshing of walls, first of all I have to draw the walls for in the elevations. For example, in this bay, so here I will select all stories and select the wall, draw wall in plan. Here I will select my wall type. Basically I have defined the wall 200 millimeter in the previous lectures. So here I will draw the wall only in one story. Automatically the wall will be drawn in the all stories. Here is the starting point. Here is the ending point of the wall. Here you can see I have drawn the wall only in the one story. Then the wall will be drawn in the all the stories. So here I will select object type and select walls. When I select walls will be selected. Then I will go in the assign shell wall auto mesh options. Again there is multiple options. So now I will select auto rectangular mesh option. There are other options, you can play with that. I am showing the options which with which I am comfortable. I am a structural engineer, so these are the options. So here again is the box size is 3 feet by 3 feet. That is the one side dimension of the box. Okay, apply. Okay. If you still are not seeing the meshing, you can again see the meshing in the shell analysis mesh. Apply. Okay, now you can also see the meshing are also appearing in the walls. Now I will show the mesh options for the beams, columns. So here I will select the object type in the column, beams, columns, beams, braces, all these are beams types. I will select. Okay, go to assign, then the frame, frame auto mesh options. So here I will select the auto mesh at intermediate joints and intersecting frames / edges. Apply. Okay, now I will again select the, you can also select from here, get previous selection. Here when I have selected, all the selections is appear. Here you can see the auto mesh options are assigned to the beams and columns. I will again go to into the frame floor mesh options. It will basically coincide the slabs and the beams, the meshing at same points. Apply. Okay, so that's how we will prepare our model for the finite element analysis in ETABS. So that's all for meshing. Thank you. In the last lecture, I have discussed about how to define the peer labels and assign to the walls. How can we check that is it assigned the peer labels? I will right click on the wall and here you can see the peer label P1 assigned. I want to just see these walls, shear walls or concrete walls. I will select object type, walls, select, close and right click, show selected objects only. Here now I will see the peer labels of shear wall, P2 core wall. Here is P2 core wall. So I have assigned the peer labels, same peer label to the whole the core. Now I will also discuss what happen if we assign the peer label to the whole the wall or if we assign separately to each wall. So let's run, and before running the model, every time I suggest and I highly recommend you to please check your model for geometry purpose. I am checking model, check model, select all. This is the accuracy. Okay, it will take just few seconds and then it will tell if there is any error in your model. Model has been checked, no warning messages were generated. If my slabs are overlapping, beams are overlapping, our columns are not to the properly jointed, so all errors will appear in this message box. So now I will run the analysis and design and I will discuss what will happen. I am running the analysis. Okay, that's the meshing we have done, and in this there is no meshing is showing because there is default set. For straight walls there is no meshing option. Here you can see when define, select the area and go to assign shell. Because I have run the model, so that's why the auto mesh option is disabled, so I will discuss also later. For the straight objects, ETABS do not create the meshing. We have to create it manually, like by selecting how many boxes we want and how much size we want. And now I will see the I will run the design, shear wall design. Here you can see the for this whole wall the one value is appearing, that is 6.2, and for pair labels that we have assigned to the walls, for each pair label in the ETABS show two results at top and at bottom. So here I am right clicking this wall, this is pair P1. So here top and bottom required reinforcement rebar area, and so that's how whole the summary you can study. But my main focus is here for whole the core only values. Here you can see for top and bottom 7.5. I'm right click. Here is whole shear wall leg is divided into legs. For example, leg 1, leg 2, leg 3, leg 4. These are the legs of the shear wall, and the reinforcement value is given by the ETABS is only one value for the whole the core, not for each wall. Basically, this reinforcement should be divided into all the walls. So why this is happening? Because we have assigned the one pair label to all the walls. Here is a required rebar area 7.2 inch square at top and 15.86 inch square at the bottom. So how we can separate and discuss separately, and one option we have also not discussed in the last section, that is spandrel beam. So these shear walls are connected these horizontal elements, these horizontal elements acting like a beam or D-beam. So we have to assign to these shear walls as a spandrel label. We will also define for example, here is a pair labels, here is a spandrel labels. So here is S1, S2, S3, S4. You can assign one spandrel label to all the at all story levels, or you can assign differently. Here I am assigning S3, S4. Okay. So now I will also make the pair labels. For example, for this back wall that will be P2, because for this wall I have assigned P1. This will be P2, P3, P4, P5, P6, and the spandrel labels will be assigned here. Now you can see that this 17.2 and 15.8. Please remember as a reference, because we will discuss after separating the pair labels to each wall. Here I have check, and I have to also discuss the meshing. Why not meshing is appearing? I have clicked assign shell auto mesh option. So here is a default, no meshing for straight walls. So if the walls are curved, then meshing will be shown. If we want their meshing should be shown, we have to click auto rectangular mesh and this size. So then software will do the meshing. For example, I am doing for this only wall. Okay, apply. I have done this meshing. Why not is appearing? I can check set display options, shell analysis mesh, apply. Okay, here you can see meshing is appearing here. So now I have unchecked. Now I will go in the plan, story 4, apply. Okay, now I will define the pair labels for all the walls. P1 for the left wall, this left wall. For all these I will generate the pair labels. For example, P2, P3, P4, P5, P2, P3, P4, P5, 2, 3, 4, 5, 6. So 6 labels are required. 6. Okay. Now I will select similar story or all stories option, and I will select this wall. Here I have selected this wall, and I am assigning the pair label it to P2. Shell peer labels, P2, apply. So now I will select this wall, I will assign it to P3, select this wall, P4, select this small wall, P5, apply, and select this wall, P6, apply. Okay, so now in the 3D view I can see the peer labels assigned. Now I will select one by one for the spandrel beams. For the peer labels, ETABS show the results at top and bottom, and for spandrels, ETABS show results for left and right options. So I will just select this concrete wall and assign shell spandrel label. Here I am selecting top one is F4 S4. Basically I have selected all stories. This is also okay. S4 is for all the stories. If you want to assign the different for different stories, for example here on one story, now I will select this one, assign S3, select this one, assign S2, select this one, assign S1. So here I have assigned the peer labels different for each wall and spandrel labels different for each floor level. Now I will again run analysis. The analysis result is taking time. It depends on your computer processor speed, RAM, etc. specification. So if your computer have high specification, then it will take less time. Now after running the analysis, I will go in the design, shear wall design, start and check shear wall design. Now it will design each wall separately and show the reinforcement for each wall separately, so we can interpret results easily. And further, it will not disturb the integrity of the walls and not disturb any results. This method is also okay, and I prefer this method as more because it will give separate results for each wall. So here now for this one is 9.43. If you sum all the walls, again the result will be equal to that one that we have referenced in the earlier. So here if I right click, here is the top and bottom results, required reinforcement top and bottom. So that's how we can study. And for spandrel, here I am right clicking, sorry, basically what happened, two labels have been assigned to this spandrel. We have not removed the peer label from this wall, so that's why this is option is appearing. I will again unlock this model because we can't assign the two labels to one element. So now I will select all. Here I have selected all the. Now I will go assign shell peer labels. Now I will select none, apply, okay. So now I can see what is, there's no peer label and this spandrel is assigned. That's the good thing, because if I have shown the error is or the bug is appeared in our model and I have removed that model, it will be a good thing for understanding. Now I will run design for shear wall. Now you will see in the spandrel left and right results will be displayed. So here for basically the spandrel's results are not appearing, only the peer label results are appearing. For showing the results in the spandrel, I will go in the shear wall design, display design info, and here I will select there is peer longitudinal reinforcement. Now I will select spandrel longitudinal reinforcement, apply. Okay, and you can see here the above results. Here I want to zoom. Here is the left and right results. Here left and right reinforcement 1.97 and 1.71 inch scale is required. There is also one beautiful option, that is a detailing. So I will also run detailing. Here I will see detailing wall details. Here is a concrete wall 1, concrete wall 2, and let's see what is saying for the concrete wall. First I have to say what is here. That is a concrete wall 2, that is a concrete wall 1. So I want to see the results for F1 elevation. Here you can see F1 elevation results and detailing is appearing. So this is a schematic view for example F3 elevation. So that's how the ETABS show the detailing. You can further study the drawings, default drawings, journal drawings. So after that you can study the symbols. So that's all for peer label and spandrel label. Thank you. In this lecture I will discuss about the peer labels. Here we are seeing a concrete wall that is on the left side of the building, and let's check that I have clicked the wall, and here is a peer, and peer label is nothing. There is no label has assigned, because when I have drawn the wall, the ETABS take the walls as a concrete walls as a shells. It means it takes only out of plane moments, do not take in plane moments. So to make concrete walls to act like as a columns, to take moments in plane moments, all the moments to carry from slabs to the to take themselves and then move towards the ground. So for that we have to assign the walls, concrete walls, peer labels. So how we assign the peer labels? So in this model right now there is only one concrete wall. Now I will also make a core concrete wall as a shear wall for the building. So here is a option for draw. I will click in the plan, draw walls. Here is a predefined concrete walls or shear walls or core walls given by the ETABS. So here is different. So now I will just select this option, this U shape type shear wall. So all the settings you can change. What is the LX? Here is LX 10.82. so it's the inner walls distance you can change. Right now for example I will change it to 12 feet, and the LY to for example 10 feet. Wall thickness right now it's 11.8. I will taking as a 12 inch, and opening, all the things you can adjust according to your requirement. So here I will click OK, and right now I will just go there and draw the shear wall. So here I have selected the shear wall, and shear wall automatically drawn in all the walls from top to bottom because it acts as a lift. So here is the setting. If you want to make the story from only from 3 to 4, then you can select up to your requirement. Because I have just selected as a lift well or lift wall for the building, so that's why its setting is from. Here I am deselecting. Here after deselecting, so now I will go in the, for example, let's see, in the 3D. Here is the rotate. Here you can see the lift well is drawn. So I will just go in the plan, base, apply. Here I will select all the spots, okay, and make sure that is the one story, and assign joint restraints fixed spot, apply, okay. 3D again. Now I am coming back. So now I will make the opening in the slab. So here is the, for example, I will draw a slab, but I will do not draw a slab. I will select the property as a opening. I want to draw the opening. So when I go for opening, I am seeing the snaps. So it is making me for me easy, so that I can and click. If you do not find the points, or you are unable to click these intersection points, so here right click, again escape, right click, snap option. So here line ends and midpoints, lines and frames, edges. So here you can select the snap settings or even the grid points. So it's up to you. If you are not able to click the points, for example, here I have selected opening, so I will select all stories, make the opening in all the stories from top roof to the base of the building. Here escape. So here I have make the hole in hall of the concrete wall. So now I will just go in the select object type, walls, select. All the walls in the model are selected. Now I will go in the view, show selected objects only the selected objects will be visible. Plan, apply, okay. So now I will define the peer labels, define peer labels. Here is already P1 and P2 are defined, so I will just delete the P2 and make P2 core wall. So add new peer label, here P1 and P2, okay. So now I will select this wall and assign shell peer label P1, apply. Here is a P2. By default, ETABS automatically also assign the peer labels to the wall, but sometimes it do not do. You have to make sure that ETABS didn't define the peer labels correctly. So now I select all the slabs again, all the walls again, and apply. Here P1 and P2 core wall. So now ETABS will also calculate the reinforcement in the walls. All the things will take care by understanding that the user have defined the peer labels. So that's how we define the peer labels in the ETABS. Now for the defining of wind loads, I will go in the define load patterns. I will write wind, select the load type wind, and select the code according to which I want to apply the wind loads. I will select UBTC 97. You can select the code according to your location of your country. Here wind load or your country, which code is following, UBC 97. So here are the parameters for the wind load. So there are basically two different options for the wind load application. First one is exposure from extent of diaphragms, and second exposure from shell objects. When you select the second option, then these parameters will become inactive. Here you can see. So I will discuss the second parameter later. For the first parameter, here is the windward coefficients and leeward coefficient. And for example, in the plain areas where there is no gable roofs, for example, only the wind load applied on the walls, for that you can select the parameters. For the wall, method 1, normal force method, windward wall 0.8 inward, and for leeward wall 0.5 outward. And for similarly for roofs, windward roofs, for leeward roofs, depending upon the slope, you can select the parameters. Here is 0.8 and 0.5. So here 0.8 and 0.5. And wind load directions and exposure widths. Here you can put manually by yourself, or software automatically calculate. And first one is 0 degree for x direction, 2 is the 90 degree for y direction. So how this works? For example, if in a city the maximum speed I will put here. So for example, in our area the maximum speed is 105, and the exposure type, there are 3 exposure type, B, C, D. It depends upon the building location. If the building situated near the sea area or in the plain area, then the wind effect will be more. And if the building located in the congested area in a advanced city, then the wind effects on the buildings will become less. So depending upon the exposure type, you will select the category exposure type. Importance factor, similarly it depends upon the buildings. And from where to where we want to apply, from the base of the story to the top story. So what is the exposure type? Here is a basic wind speed definition. Exposure type B has a terrain with buildings, forest or surface irregularities covering at least 20% of the ground level area extending 1 mile or more from a site. Exposure C has a terrain is a flat and generally open extending 0.5 mile or more than the side any full quadrant. Exposure D represent the most severe exposure areas with basic wind speed 80 miles per hour or more. So exposure D is a severe condition, it's a normal, and it's a minimum condition. So you will select according to the type. So its speed is wind speed is 105. So we have also see that our building is going to locate in which area. It's a open terrain, or there are a lot of buildings, so you can select accordingly. If you do not know, select the C category. Then these are the factors. Okay, and then software automatically calculate the parameters. You do not need in this calculation, or you can do by your own self. So how software calculate by own? I will click OK. So here I will just quickly draw the beams. For example, for drawing of beams, here is a column. I will just select all stories, and I can click one by one for the drawing of columns. Now for the illustration of the wind loads, I will quickly draw a building. Here is a column 300 by 300. Here is, I have selected all stories. When I click in the one story, in the all stories column automatically drawn. For the quick way, you can select by this way. So here I have drawn the columns quickly. So now I will draw the slabs quickly. How? Here is a quick draw slab. Quick draw slab, you will select the property slab 150 millimeter, which is I have defined here. Here you can see slabs automatically created in the all floors, but at the bottom we do not need. I will remove by going there, go into the plan, base, apply. When I will go, I will select only one story. If I select all stories, click one, all stories will be selected automatically here. But I do not want, I just want to remove the bottom base story. I will delete. So here now the buildings are looking good. The boundary conditions are hinge. I will assign it to pin one story. I will select all the base and assign joint. Joint restraint is the boundary condition. I will select fix. That will restrict all the deformations and rotations. For hinge only deformation exists, moments will not exist. So I will select fix and condition, apply. Okay, if there is not, just click here, refresh. Now you can see boundary conditions are applied. So now I will assign the diaphragm. Here I will check first diaphragm, modify. Yes, rigid diaphragm is defined. What is rigid and semi-rigid? You can check it's the flexibility of the your slab. I will select all the slabs, select properties, slab sections, slab 150 millimeter. Okay, so now I can assign shell diaphragms D1, apply. Okay, so it is showing the diaphragm extent. I can disappear this diaphragm extent by going here, uncheck this, apply. So here diaphragm extent is removed. I have assigned all the slabs the rigid diaphragm. Now you can see the software automatically applies to the wind load to the structure. So here load pattern, wind, modify. Here you can see the location, width, depth, x ordinate, y ordinate. Then the second option is of wind. We can select the exposure from shell objects. For that we have to create the cladding around the building. For example, now I am going to create a cladding around the building. I have selected the 3D view and draw auto cladding. Use floors, between the floors automatically create the cladding. Use beams, use columns, so whatsoever the way you like. For example, I have selected the use floors. Okay, now you can check the software automatically assign the cladding to the building. So the cladding is that thing in the software which do not have mass and do not have stiffness. It only going to calculate the wind pressure to the beams, columns and the slabs. So here I will select all the I will go into the A, elevation, A, apply. Okay, I will select all the X sides 3D and assign shell loads, and from here wind coefficient. So here for the windward pressure I will appoint 8 for the windward, wind, apply. So here you can see the inward 0.8, software automatically calculates this value. When we refresh and run the analysis, we can see these values here for the wind loads. For example, now if I run the model, I can see the values. Okay, this is deformation model. I will for the wind response I will go in the maximum story displacement due to wind. So here you can see the displacements. X is blue, which is showing the x direction because we have applied the loading in the x direction. For the levered, we will select the x negative side and apply the levered pressure. So here you can see the displacement, maximum displacement appearing here. Now we will also see the loads, display load assignments to the shells, wind load, apply. So here you can see the parameters now. 0.8 W, 7.4. Software automatically calculates. These are the two ways for defining the load for the wind load pattern. So here I have selected the second option. So I have taught both options. It is up to you. You can select which option is better for you. Thank you. In this lecture, I will show you how you can apply P delta effects. Is it the requirement of the structure that P delta effects need to be considered or not? First of all, little bit about P delta. Here is for example, a simple structure. Here, that is a building. Consider that is a building of height h. The load is applied P. Then the